Today's class we will learn about the problem using the Fourier series method. This is a given problem. Design an ideal low pass filter with a frequency response. Frequency response is given for omega minus pi by 2 to plus pi by 2. So that is amplitude is 1 and 0 for pi by 2 to pi. Find the values of h of n, that is filter coefficients, for n is equals to 11, right? Here itself you can identify what is the n value. The n value is odd or even? Odd value. Find h of j and plot the magnitude response using the Fourier series method and rectangular window method. Solution. First, given h of e power j omega is equals to, the amplitude is 1 and we have the omega values, that is minus pi by 2 to less than pi by 2, omega less than or equals to pi by 2, and 0 for minus pi by 2 less than or equals to mod omega less than or equals to pi. So if you are identifying the entire omega, x-axis is omega and y-axis is h of e power j omega. Next, this is a 0. So if you are identifying the omega value is minus pi to plus pi, isn't it? Now in between minus pi by 2 to plus pi by 2, minus pi to plus pi, somewhere we will have minus pi by 2 and somewhere we will have a plus pi by 2. Now what is the amplitude at minus pi by 2 to plus pi by 2? The amplitude is 1. Okay, so we have to design ideal low pass filter. So this is a characteristics of the low pass filter, ideal low pass filter. Then minus pi to minus pi by 2, what is the amplitude? The amplitude is 0. Again here mod omega means plus or minus omega. So we have minus pi to minus pi by 2 as one range, the amplitude is 0, as well as plus pi by 2 to plus pi, the amplitude is 0 again. Now coming to step number 1. So here itself you can identify the h of n is equal to h of minus n. Is it symmetric or antisymmetric? Symmetric in nature. So it is the h of, first step, the h of e power j omega is symmetric in nature, symmetric with what is n value? N value is odd in nature. So this is a condition. So first step is we have to observe the given h of e power j omega, whether it is symmetric n is equal to odd, or it is symmetric n value which is even, or antisymmetric n value may be odd or even. So depending upon the given expression, we have identified that it is a symmetric when n is equals to 1. Suppose if I have this type of structure, now tell me, is it symmetric or antisymmetric? Antisymmetric, because 0 to here these values are differed by minus n. So h of minus n. But here in this case h of n is equals to h of minus n. So therefore it is a symmetric in nature. Now step number 2. Step number 2 is find the hd of n from the given h of e power j omega. The formula is 1 by 2 pi integral minus pi to plus pi h of e power j omega into e power j omega and d omega. Now h of e power j omega we have a range. So if I substitute the same, I will get hd of n is equals to 1 by 2 pi integral of, so this integral I am differentiating with first minus pi to minus pi by 2 h of e power j omega. I am splitting entire minus pi to plus pi as minus pi by 2 to pi by 2 h of e power j omega n into d omega plus one more integral between pi by 2 to pi. So we already know that from the given So integral is existed between only minus pi by 2 to plus pi by 2. So this entire integral will be 0 and this the last integral also will be 0. So overall multiply by 1 by 2 pi. Now using the given expression, the HDO of n is existed between only minus pi by 2 to plus pi by 2. So minus pi by 2 to plus pi by 2, the amplitude is 1 multiplied by e power j omega n d omega. We know that integral of e power j into x dx is equals to e power j ax divided by ja. Similarly, here we have e power j omega n. The integral of e power j omega n will be is equals to e power j omega n divided by, what is the variable here? Omega is the variable. So j n. The limits are minus pi by 2 to plus pi by 2. Now substitute the upper limit minus substitute the lower limit. So you will have 1 by 2 pi. If I substitute omega by pi by 2, e power j n pi by 2 minus e power minus j n pi by 2. So first omega value is divided by j n. First omega value is here pi by 2 and next value the omega value is minus pi by 2. Now we know from the trigonometric series sin theta is equals to e power j theta minus e power minus j theta divided by 2j. Same way, we have here HDO of n is equals to e power j theta minus e power minus j theta divided by 2nj. If I write the same, I will get it as sin the theta value is n pi by 2 divided by n pi. Give it as equation number 2. First, given expression is equation number 1. This is equation number 1. Now, the HDO of n, that is equals to equation number 2. Step number 3. Step 3. So we have the impulse response is equals to desired impulse response if we are using the Fourier series method. Suppose if you are using the windowing technique, that is a rectangular window, then h of n will be is equals to hd of n into omega of n, omega r of n. R stands for W of n is windowing technique and R stands for it is a rectangular window. If it is a rectangular window technique, then this window W R of n is equals to 1 for the minus of n minus 1 by 2 to n value is between n minus 1 by 2 and 0 otherwise. So what is given n value? The given n value is 11. 11 minus 1 by 2, 10 by 2, that is 5. So this rectangular window W R of n is equals to 1 for n value between minus 5 to plus 5 and 0 elsewhere, remaining all values. So because this rectangular window, so here the HD of n is it is a n value is minus infinity to plus infinity. But what we are doing here, using the windowing technique, we are truncating down the n value that is minus infinity to plus infinity to the specific n value that is minus n by 2, n minus 1 by 2 to plus n minus 1 by 2. Now give it as equation number 3. Equation number 3. Next, step 4. Step 4. Right. From the given frequency, response of the filter, coefficients are satisfying symmetric property, that is h of n is equal to h of minus n. Now we are finding the h of n coefficients for different n values. So first we have from equation number 2 as hd of n is equals to sin n pi by 2 divided by n pi. If I substitute n value between 0 to 5, suppose n is equal to 0. If I substitute n is equal to 0, then hd of 0 is equals to sin 0 divided by 0. So what is sin 0 value? 0 divided by 0. So here we are getting the 0 by 0 form. So therefore we have to apply the L'Hospital rule. Okay. So L'Hospital rule is saying that limit n tends to theta tends to 0, sin n theta by n theta is equals to 1. Using the same L'Hospital rule, hd of n I am writing down as limit n tends to 0, sin n pi by 2 divided by, here I am multiplying and dividing by, in the denominator I have only n pi. So that's why I am multiplying and dividing by 2. So therefore I have 1 by 2 which is a constant, limit n tends to 0, sin n pi by 2 divided by n pi by 2. The answer is overall this limit will be equals to 1. That is I have the hd of 0, the very first value for n is equal to 0, that is 1 by 2. So this is the first filter coefficient for n value, that is 0. Is equal to 1. So for n is equal to 0, we have hd of 0 is equals to 1 by 2. Now substitute n is equals to 1. Then if you are substituting n is equals to 1 in hd of n, then hd of 1 is equals to hd of minus 1 is equals to, because of symmetric in nature, so sin n value is 1, n pi by 2, that is pi by 2 divided by n pi, n value is 1. So sin pi by 2 value is 1 by pi. Now 1 by pi value is 0.3183. Again substitute n is equals to 2. Then hd of 2 is equals to hd of minus 2, that is equals to sin of n pi by 2, that is 2 pi by 2 divided by 2 pi. So sin pi, the value is 0, 0 by 2 pi is equals to 0. Now next coefficient, n is equal to 3. For n is equal to 3, hd of 3 is equals to hd of minus 3. Now up to how many values we have to substitute? N is equals to up to 5. So 0, n is equals to 1, n is equal to 2, 3, n is equal to 4 and 5. Then sin 3 pi by 2 divided by 3 pi. So sin 3 pi by 2 value is minus 1 divided by 3 pi is equals to minus 0.106. Now substitute n is equals to 4. Then hd of 4 is equals to hd of minus 4 is equal to sine 4 pi by 2 divided by 4 pi. Again it is 0. Sine 2 pi value, that is 0. Now last value n is equal to 5. hd of 5 is equals to hd of minus 5. Then sine 5 pi by 2 divided by 5 pi. So sine 5 pi value is 1. 1 by 5 pi is equals to 0.0636. Now from equation number 3 and n is equals to 11, we have the rectangular window. Now for n is equals to 11 and from the equation number 3 we have to find out WR of n for different n values. So in general it is 1 from n value from minus 5 to plus 5 and 0 otherwise. If I substitute n is equal to 0, then WR of 0 is equals to 1. If I substitute n is equal to 1, the WR of 1 is equals to, again it is 1. N is equal to 2. So it is same as WR of minus 1. If n is equal to 2, then WR of 2 is equal to WR of minus 2 is equals to 1. If n is equal to 3, then we have n is equal to 3 or n is equal to minus 3 will have a same value. If n is equal to 4, then also it is the same value because it is not depends on n value. Throughout the n values from minus 5 to plus 5, the value is 1. Now from equation number 3, from 3 we have h of n is equals to hd of n into WR of n. Now when n is equal to 0, then h of 0 is equals to hd of 0 into WR of 0. We know what is hd of 0 coefficient? 1 by 2, that is 0.5 into 1 is equal to 0.5. This is our final filter coefficient. Now n is equal to 1, then h of 1 is equals to hd of 1 into WR of 1. So what is hd? h of 1, hd of 1, that is 0.3183 into 1. When n is equal to 2, then h of 2 is equals to hd of 2 into WR of 2. Again 0 into 1, that is 0. If n is equal to 3, then h of 3 is equals to hd of 3 into WR of 3. So hd of 3 value is minus 0.106 into 1. And remember, all these values are same as h of minus 1, h of minus 2, h of minus 3, minus 4, h of minus 5 because of symmetric property. Now if n is equal to 4, then we will have a coefficient as 0 into 1, that is 0, is equal to h of minus 4. Now if n is equal to 5, we have h of 5 is equals to hd of 5 into WR of 5 is equals to, the last coefficient is 0.0636. So this is same as h of minus 5. Step number 4. Step 5. So step 5 is find the transfer function of the filter, and it is given by h of z is equals to h of 0, already we have determined this h of 0 from the above analysis, plus summation of n is equal to 1 to n minus 1 by 2 h of n of z power n plus z power minus n. This is the formula. Now h of z is equals to, substitute the n value which is 1 to n value is 11, 11 minus 1 by 2 that is 5. H of n plus z power n plus z power minus n. Now h of 0 plus, substitute n is equal to 1, you will get h of 1 into z power 1 plus z power minus 1. N is equal to 2, z power 2 plus z power minus 2. N is equal to 3, z power 3 plus z power minus 3. N is equal to 4, up to n is equal to 5 you have to substitute. The last value is z power 5 plus z power minus 5. Now we have the coefficients h of 0 to h of 5 from the above analysis. Substitute all those values in h of z. So h of z is equals to, h of 0 value is 0.5 plus h of 1 value 0.318 into z power 1 plus z power minus 1. H of 2 value minus 0.106 z square plus z power minus 2. H of 3 value 0.0636. So h of 3 value is 0 as well as, so this is h of 2 value is 0, h of 2 0 as well as h of 4 is 0. So I am not writing those expressions. So this is 0 and this also 0. So h of 5 into 0. H of 5 value 0.0636 into z power 5 plus z power minus 5. Now this is our non-realizable filter transfer function. Next step is writing the realizable transfer function by multiplying z power of minus n minus 1 by 2. Now step number 6. The transfer function of realizable filter is h dash of z is equals to multiply h of z with z power minus of n minus 1 by 2. So n value is 11, 11 minus 1 by 2 that is equals to 5. So z power minus 5 into h of z. So where you have h of z already, multiply that h of z with z power minus 5. So if I multiply the h of z with z power minus 5, then I will get the realizable filter transfer function. H dash of z is equals to, so this is our final overall the non-realizable filter transfer function. After multiplying and writing in the sequence order, this we it as equation number 4. We have the starting first constant term up to z power minus 10. In terms of filter realization, we have this expression. From this expression we can able to realize the system, right? See here the first coefficient is equals to same last coefficient. Next h of 1 coefficient is equals to h of 9 coefficient, right? So that is 0. Then h of minus 2 coefficient is equal to, that is h of n is equals to h of n minus 1 minus n. Here it is satisfying, right? Same next step is, now from the above analysis we have identified that h of n is equal to h of n minus 1 minus n. Therefore the filter coefficient of causal filter is h of 0 coefficient is equals to h of 10 coefficient, n minus 1 minus n. N value is 11, 11 minus 1 that is 10 minus n. If n is equal to 0, h of 0 coefficient is equals to h of 10. Therefore the coefficient is 0.0636. If n is equals to 1, h of 1 coefficient is equal to h of 9 coefficient, that is equal to 0. Next h of 2 coefficient is equal to h of 8, that is equal to minus 0.106. If n is equal to 3, that coefficient is equals to h of 7, that is equal to again 0. N is equal to 4 is equal to n is equal to 6, 0.318. Again h of 5 is equal to 0.5. Now next step number 8. Magnitude response of FIR filter. So we know it is a symmetric and n is equals to odd. From the yesterday's class we have discussed about the table where n is odd value and given response is symmetric in nature. From that we have h of e power j omega is equals to summation n is equal to 0 to n minus 1 by 2 a of n cos of omega n. Now substitute the order of the filter, that is 11. So if you are substituting n value between 0 to 5, a of n into cos of omega n. Now when n is equal to 0, we have one more formula, a of 0, to finding the coefficient h of n minus 1 by 2. If I substitute n value as 11, then a of 0 is equals to the coefficient of h of 5. From the above analysis, the h of 5 coefficient is equals to 0.5. Now in order to find out a of n, so in the formula we have a of n. If I substitute n is equal to 0, I will get it as a of 0. So we have separate formula for a of 0 finding the a of n. So a of n is equals to 2 into h of n minus 1 by 2 minus n. Now again substitute n value between 0, already we have find out, that is a of 0 is equal to 0.5. Now substitute n value as between 1 to 5. If n is equals to 1, we have a of 1 is equals to 2 into h of 5 minus 1, n minus 1 by 2, that is 10 minus, that is 5 minus 1, that is 4. 2 into h of 4. From above analysis we have h of 4 value, that is equals to 0.318, that is equal to 0.636. Again substitute n is equal to 2. Therefore a of 2 is equals to 2 into h of 5 minus 2, that is 3. So h of 3 value is 0, 2 into 0, the coefficient is 0. Now substitute n is equal to 3. If I substitute n is equal to 3 value, n is equal to 3, a of 3 is equal to 2 into h of 2, the h of 2 value is minus 0.106, that is equal to minus 0.212. n is equal to 4, a of 4 is equals to 2 into h of 5 minus 4, that is 1, is equal to 2 into 0, 0. n is equal to 5, a of 5 is equals to 2 into h of 5 minus 5, that is 0, is equal to 2 into 0.0636, 0.1272. Now these values we have to substitute in h of e power j omega is equal to, the formula is summation of n is equal to 0 to 5 a of n into cos of omega n. Now substitute n values and elaborate the summation. A of 0 cos 0, that is 1 cos 0, plus a of 1 into cos of omega, plus a of 2 into cos of 2 omega, plus a of 3 into cos of 3 omega, plus a of 4 into cos of 4 omega, plus a of 5 into cos of 5 omega. Now substitute a of 0 value, a of 1 value in the above expression. We will have a of 0 value is 0.5 plus 0.3636 cos omega minus 0.212 cos 3 omega plus 0.1272 cos 5 omega. This is our final magnitude response, it is frequency response of the FIR filter. So this table indicates that for different omega values what will be our frequency response. So first I am considering the omega value as 0, then 30 degrees, then 60 degrees, 90 plus 30 that is 120, 120 plus 30 150 degrees and last 180 degrees. If I substitute the same in the above expression, I will get the magnitude as 0.151, 0.940 and the phase value is 0.4 and 0.517, 1.09 for 6 omega is equal to 60 degrees, 1 by root 2 that is a phase, 0.5 minus 6 minus 0.09 minus 20.6, 0.059 minus 24.7 degrees minus 0.051 and minus 26. Therefore, from the above table, if I draw the response or the characteristics of the low pass FIR filter, so I will get the characteristics like this. So, final frequency response of low pass filter. Whether you are considering FIR filter or IR filter, the characteristics are same. But these are, so given response is an ideal response, but we got practical characteristics. That is the use of advantages of FIR filters. This filter is very stable in nature because of these characteristics.